Hey, by the way, let me give you guys a little FYI. You know, I record in here and put in Canvas so that people who are absent or people who need to listen again can do so. And I had someone share with me last night who is obviously not in your class, but is listening to the recordings from here. And he said, I really appreciate that you put those on YouTube so that I can go back and look at them again. And he said, but boy, you sure have to tell your class to be quiet a lot. Ooh, yeah, because you guys are so chatty. So let's see if we can improve on that today. Now, we're going to talk about correlation. Okay, correlation. And that simply means there is some kind of relationship between two variables if they have a correlation, all right? This is very familiar to you guys. Ordered pairs, x comes first, y second, right? What do we usually call the x variable? It's the independent variable. Now hang on. In statistics, we sometimes call it the explanatory variable. So when you shift over to statistics, sometimes we have different names for things. In algebra, we would say the y variable is the, not independent, but dependent variable. In statistics, we'll call it the response variable. So think about that for a minute. That's kind of logical, right? That if I do something with the x, it causes the y to respond, all right? Now, a scatter plot can be used to determine whether you get a linear correlation between two variables, right? Because all a scatter plot is I plot points and then I can see if it looks like I have a line. So for example, here is a scatter plot. Would you say that this is approximately linear? Is it exactly linear? No. If I tried to put a straight edge up here, I can't get all of these points on the same line. This guy looks like he's a little out of whack compared to the others, but it definitely is pretty close to a straight line. Agreed? Okay, so we would say it is approximately linear. It suggests a line. Now, there are types of correlation you have to be able to identify. The first type is a negative linear correlation. Now, this definitely is not completely linear, but if you sort of thought of that line as being a little bit wider, a little fatter, then doesn't it look like you've got a line that's going which way, up or down? Down. As I move from left to right, it's decreasing. That means that if it had a slope, I would have what kind of slope, positive or negative? Negative. So that's why it's a negative linear correlation. I bet you can tell me why this is positive. Because if I were describing the slope, it would be increasing, so it's going up. Now, sometimes you put points on a scatter plot and it looks like this. Does anybody see a line in there? I hope not. Yeah, we need to go get your eyes checked if you do. This is kind of like buckshot everywhere, okay? So lots of random points. There is no general shape. But you know, sometimes you can get something that looks like this. Now that's not linear, but it kind of looks like what shape? A parabola. It looks like it came from a quadratic equation. That means there is a correlation, but it's not linear. It's a nonlinear correlation. We will not deal with those in this course. We just know that they could exist. We're going to be talking about linear correlations. So, first thing we're supposed to do is construct a scatter plot. Here's the data that they've given us. There's an economist who wants to determine whether there is a linear relationship between a country's GDP, gross domestic product, and their carbon dioxide emissions. Sounds kind of like a global warming thing, doesn't it? Data are shown in the table. Display the data in a scatter plot and determine whether there appears to be a positive or a negative or no linear correlation. So you see your note sheet and you see this blank space here. Guess what you're supposed to do on it? You're going to put this scatter plot on here. Now, I know, doesn't this sound like fun?
Oh, yeah.
Oh, yeah. So let me switch over for a second to this. Okay. I did. I got the stuff put on here, so now we can go back and forth. So that's a good deal. All right, so here's what I'm going to get you started, and then you're going to finish this thing up. If I'm going to do a scatter plot, real world things typically don't involve negatives. So almost any set of data you're going to be given in this course, everything is probably going to be positive. Now, if it's not, that means we would need to draw more than the first quadrant. But if all my x's are positive and all my y's are positive, do I need to draw 4 quadrants? No, I just need to have, kind of like we did with the histograms, we'll draw a first quadrant graph. Make sure when you draw it, you label your x-axis, you label your y-axis. What else do you think we would need to put on here? Okay, I need a scale. I'm going to have to come up with some sort of scale. Now, if I'm looking at my x values, the smallest number in the x column is what? 0.9. What's the largest? 4.9. So my smallest is 0.9, my largest is 4.9. That's not a very big spread. So I don't know that I want to count by ones because I have all these decimals, but I don't think I want to count by tenths and have to go all the way up to 4.9. You get to decide how you want to label the scale. You just have to be sure you're uniform in how you label it. So what do you say? How would you count? 0.5s? So maybe if we did 0.5, 1.0, 1.5, 2.0, 2.5, 3.0. Are we having fun? Aw. Now I need to make this a little bit bigger. We are having fun, aren't we? Okay. So I think I would need to go up to probably 5.0 on my x-axis to make sure I've got everything, enough room for everything. And before I move to my y-axis, there's one more thing I probably need to put on my x-axis. What do you think it would be?
0.
Well, 0 is sort of understood. I need to put what? If I have a gap, I would put that little squiggle in there. I don't think I need it since I'm counting by 0.5s. Look at what the x's are supposed to represent. I would put GDP, gross domestic product, and if you want to add in trillions of dollars, you can. But the main thing is you need GDP, okay? Because you got to tell me what that x-axis represents. Now, my y-axis, if I look at the numbers in the table, I don't think I want to count by 0.5s. Do you? Oh my goodness, because the smallest number here is what? I think it's 264. What's the biggest one? 1214.2. Okay, these numbers look nothing like the x's. So I've got to have a completely different scale for the y's. What do you think you might want to count by here? How much?
200.
Okay, I got a suggestion for 200s. What do you guys think? Yeah, if you want to count by 100s, you can. If you want to count by 200s, you can. And so I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to go ahead and count by 100s. And I need to label this. And what else should I put on this y-axis? What does it represent? CO2 emissions. Okay. All right, I'm going to get you started with the first point, and then I'll let you finish getting the rest of your points on. So if my first point occurs at 1.6, 428.2, I'm going to go to the x-axis, And I'm going to have to estimate where I think 1.6 is. So it's going to be a little past 1.5. I got to go up to 428.2. So maybe about there. And that would be my first point. Okay, you guys put the rest of them on for me. Okay, I want to go back to the slideshow. I'm not there yet. Hold on. Come on. Here we go. It's supposed to be. There we go. Okay. So we are looking at a scatter plot that looks something like this. Now, they did count by ones on their exit. Remember I said you get to pick your scale. And they counted actually by 400s, but they started at 200 on the y-axis. But I would say we all pretty well have an idea that this is the basic shape of this graph. It may get stretched a little bit if we counted, like I counted by 100s on my y-scale, so that kind of made mine stretch out a little bit more. But this is the basic shape. And if I were to ask you, looking at the scatter plot, would you say there's a negative, a positive, or no linear correlation? You'd tell me what? Yeah, this is a positive linear correlation. It's not perfectly linear because they're not all in one line, but it gives the general appearance of a line. So that means as the gross domestic product increases, the carbon dioxide emissions tend to increase. Now, here's where you got to be careful. We're going to touch on this again at the end. Does the fact that there is a positive correlation mean that as gross domestic product increases, it causes the CO2 emissions to increase? It does not. We can't make that jump and assume that there's a cause and effect relationship. We can only observe that as the gross domestic product goes up, so does the CO2 emissions. There may be more reasons that are impacting those CO2 emissions than just GDP. We don't know. Now, this is the part that you guys, I think, will appreciate. We're going to talk about how you do this in the calculator. How many of you have done scatter plots in the graphing calculator before? Oh my, I expected more hands than this. Okay, well, then how many of you have a graphing calculator with you today? All right, not as many as I would like to see. So if you don't have one, you might buddy up with somebody who does and make sure that you understand the process we're going to go through to put this in. So anybody been to the Yellowstone before? Have you seen Old Faithful in person? You know what Old Faithful is, right? Okay, so it's a geyser in Yellowstone. I got to see it for the first time this last summer. We went there on vacation. It's really pretty darn awesome. But they tell you, they make a point to tell you, it is not the biggest geyser in the park. I mean, there have others that when they erupt, it's a lot more impressive. But why do they call it Old Faithful? Because it's very dependable. There's a consistency to the eruptions. Most of the other geysers, they don't really know when they're going to go off. In fact, while we were there, there was one that they talked about how monstrous it is when it erupts, but it only erupts like once every 10 years. And nobody knows when it's going to be. So if you just happen to be lucky and catch it, it's a really impressive thing. But, you know, there's no way to know when it's going to go off. So what they've done in this table is they have tracked the duration of minutes for some eruptions that Old Faithful had and the time in minutes until the next eruption. Now, if you look at this, okay, the length of the eruption, around 2 minutes, goes up to 3 minutes here. There was one that was actually 4.5 minutes. That's not a huge difference. And then if I'm looking at the length of the eruption, these all look pretty close to about a minute, right? And then some of these over here get up to about 1.5 minutes. All right. Oh, I'm sorry. No, the time, this was the time between the eruptions. So this is in minutes, which means it's closer to an hour between eruptions. And over here, it gets closer to an hour and a half. And in fact, when you go, they have little schedules that they have signs that will say when the next eruption should be. And there's a little window on it because it may be a few minutes either way, but you can see it's pretty consistent, okay? And what we want to figure out is if there is some kind of correlation that goes with this. Now, if you're looking on the handout that I gave you, all right, let me go back so we can see that screen. Okay, I've got the data that I had on the screen right here. And we need to put it in the graphing calculator. So like I said, if you don't have yours with you, then you probably want to look on with somebody and just make sure you make some notes on where we're going and how we get this in. Now, be real careful because there's so much data here. The one we did before this, there were 10 ordered pairs. This one, if I count them up, I have X's here, but I also have X's here. Altogether, I've got 25 ordered pairs, okay? So what we're going to have to do is go into stat, and then if I want to put my X's in L1, I have to hit what? Enter, and I'm going to need to put X's in L1, and I'll put the Y's in L2. So I'm going to arrow over, arrow up, and then I'll hit clear to get rid of the numbers that I have in this calculator. And I'll do that for both L1 and L2. And now be careful, because we need to type all these in carefully into L1 and L2. All right, so can you guys see those all right? And let me pause. Yes, you want to put all the X's in L1 and all the Y's in L2. Let me back on. Okay, so let me show you one more time. We were here in stat. All the numbers are finished as far as being entered in L1 and L2. So we hit second quit. We go to second Y equals to go into stat plot, and I'm going to hit enter. I've got to make sure it's turned on. So if it's on top of off and blinking, arrow over and turn it on. And then when you arrow down to type, the very first one is the scatter plot. So you want to hit enter. And it should default to tell you that your X's are L1, your Y's are in L2. Okay? Now, in order to make sure that the window is set correctly, we've got to tell the calculator, set my window based on the information that's in this stat plot that's going to come out of my L1 and L2. So that means you go to the button that says zoom, and we want to choose zoom stat, which is zoom 9. Okay, now I've got one oddball something here that looks like it doesn't belong. I bet I typed something in wrong. So I'm going to go back and look and see. I bet right there after 61, that's supposed to be 73. Let me fix that. And that's what mine looks like. Does that look anything like yours? Or is your window different? Huh?
Ours are more simple.
Yeah, I am not sure. Oops. Zoom in. Okay. Well, we'll just go with it the way that it is. There we go. That looks better, doesn't it? Is that more like yours now? So I'm looking at the graph, the scatter plot. What would you tell me? Is there a correlation here? It's what? It is a positive linear correlation. Now, let's go back to this. And this explains how you get that on your calculator screen, okay? So if all you had was a list of ordered pairs and you didn't want to have to put them on paper, just to answer the question, is there a positive, negative, or no linear correlation, you could put them in the calculator and look, okay? Now, this is the part that I don't know that you guys have done this in high school. Have you talked about something called the correlation coefficient, R, yet? Okay, we're going to talk about it. What it does is it measures the strength and direction of a linear relationship between two variables. I mean, we just looked at several plots, and you guys have been able to look and say, yeah, that's got a positive linear correlation. But is one a stronger correlation, like closer to being an exact line than the other? I don't think we could tell by looking, could we? All right, so we need a tool that would let us be able to explain how strong the correlation is, if it's very close to being perfectly linear or if it's just kind of linear. And so we use the letter R to represent the sample correlation coefficient. Remember, anytime we're working with samples, we use regular letters. If we're working with populations, we use what kind of letters? Greek letters. You will appreciate this calculator when you look at the formula you need in order to calculate R. That's a whopper, is it not? Okay, there's a lot of stuff you have to tabulate before you can plug in here. And believe it or not, we're going to look at how you do this. This is why I'm telling you, you're going to want to come with one of these calculators on the next test, okay? Because we're going to have to find all these pieces. Now, let's see if you can remember what these letters stand for. What do you think that N would represent? It's the number of data pairs. So like the Yellowstone eruptions we were just looking at, well, how many ordered pairs were there? 25. We would have 25 here for our N. What is this symbol called? That's sigma. It means you do what? Add up. And what you'd have to do is first multiply the X and the Y in every ordered pair and then add all those up. So in other words, we'd have to make a new column. We'd have to add up the X's, we'd have to add up the Y's, multiply those together, and then we'd subtract that from this, and that's just the numerator. And then you look in the denominator, you got 2 square roots with all kinds of stuff you've got to compute underneath. We're going to have fun with this, aren't we? Now, just in case you're working with a population instead of a sample, anytime we do this, we're just going to be working with R. But I just want you to know the only thing that changes is the same formula, but they'll call it rho, which looks like kind of a italicized lowercase p, but it's the Greek letter rho. All right, that's just when it's a population. We're going to be working with this, and we're going to find the R value or the correlation coefficient value, and we're always just going to use the letter R. All right, so far so good? So let me just kind of sum up what this means. Remember, it's measuring the strength and the direction of a linear relationship between two variables. So it's going to be a tool. This formula will give us the ability to say how close it is to being linear. Now, here's what you need to know. After you calculate it, you're going to get a number between -1 and +1. It does not matter how many ordered pairs you have. It does not matter what the numbers are in the ordered pairs. That's kind of cool when you think about it. It could be anything, but you're always going to come up with a number between -1 and +1 when you use that formula for R. Now, if it's -1, that tells you this thing is a perfect negative correlation. It's dead on. One line passes through all those points, okay? I bet you can tell me what you think +1 would be. Oh, come on. If -1 is a perfect linear negative correlation, what would +1 be? Perfect positive linear correlation. And then this is the part that's kind of interesting. The closer you get to 0, whether it's like -0.03 or it's +0.07, even something like 0.21 is closer to 0 than it is to 1. And the closer you get to 0, that's when it looks more like that scatter shot, and there is no linear correlation. Okay, so let me show you a few examples. That's pretty close to looking linear. Obviously, it's wider than a single line. But look at what that R value is. It's negative 0.91. I'd say that's pretty close to -1. So what that tells me is I have a strong negative correlation. This thing looks a lot like a line. It's just a little wider. And it's definitely decreasing as my x's are increasing. It's going to be a negative slope. Now, there is a strong positive correlation. The R value on that one is 0.88. Probably these guys right here that's what's keeping it down in the 80s instead of going up to the 90s, because they're a little bit more spread out here. Now, look at this thing. Does it look like a line? Kind of, if you sort of ignored these guys right here, right? So what you see is an R value of 0.42. That's actually closer to 0 than it is to 1. Agreed? That means there is a weak positive correlation. And when you get an R value that's 0.07, it's just not linear, period. Okay? So the closer you get to 0, the weaker the correlation is, and eventually you get to a point where you say, I can't even make out a line. This one you kind of can, but it's, I mean, you've definitely got some stuff that's not where you'd want it to be. So here are our symbols again. These are going to be all the pieces we're going to need in order to plug in to this formula. Okay? So I want us to do this. Let's go back to our sheet. And you remember the data that we worked with on the front that only had 10 ordered pairs. Let's work with something smaller than 25 ordered pairs. Here's what I want you to see. Here are all my X's. Here are all my Y's. In this column, because remember my formula was this right here, I've got to multiply the X's and the Y's together, and then I'm going to have to add them up. So you're going to have to take your calculator and you're going to have to multiply 1.6 times 428.2, and that number is going to go right here. Okay? Oops, 0.12. And then you're going to have to do the same thing here. We're going to have 3.6 times 828.8, and we're going to write this here. And you got to do that for every one of these. So even if you don't have a graphing calculator, you can do this. And you're going to need to do it because if you don't have a graphing calculator, you got to know how to do this by hand when you take the test. Now let's go back to the PowerPoint, and we are ready to actually plug into this equation. All right, so here's what we're going to do. All right. Let's double check in case you didn't get all the numbers written down a minute ago. Are these numbers the ones you have at the bottom of the columns? All right, so here's where we're going to plug in. Okay, so what we've done is we've plugged in all these numbers into the formula and we multiplied the numerator together and subtracted and ended up with this. My denominator is going to have 2 square roots. I would recommend, let's just get the number that goes under each square root right now. So if you were to take 10 times, let me get this where you can see it, 67.35, and then subtract the 23.1 squared, I get 139.89, right? That's what goes under the first square root. I typed it in without the radical because I'm just kind of doing it a piece at a time. So this part right here gave me the number 139.89 under the square root sign. Now let's look at the second radical. And we're going to have 10 times 3, 7, 7, 5, 8, 4, 2.76. I'm going to close that parentheses. And then I've got to subtract 5554 squared. Okay, you guys getting a number that looks like that? 6911511.6 is what's underneath the second square root sign. Are we together so far? Yes? No? Yes? Okay. Can you simplify from here? I want you to use your calculator. You're going to come up with a number for R. Now remember, R is supposed to be a number between what and what? -1 and +1. So let's see what you get when you calculate this R value.
0.88.
And let's go 4 places to the right. So you said you got 0.8825. Are y'all getting that? We got to make sure our calculator skills are solid. So if you're having any trouble, type in your numerator 27,439.7 divided by, now open a parentheses so the calculator knows the entire denominator is going to be, hit second and the x squared to get your square root sign, and then it's 139.89. Now I'm going to arrow right so I get out of the square root, and then I can do times and put in the second square root, which is 6911511.6. Now I will tell you this, if you have a calculator with one of the older operating systems, you actually can't arrow right to get out from under the radical. If it's an older one, if it's like an 83,
Yeah, you can.
it will automatically get out, I think, when you type the next thing in. I had a man last night who brought me his calculator, and you couldn't arrow right to get out from under the radical before you multiplied here. It automatically went to, if I typed in the square root, it automatically put up a new radical. It didn't put it underneath. If I don't arrow right in this operating system, it'll put a square root under the square root. You see what I'm saying? So you just got to make sure that it's one square root times another square root. And now when I hit enter, this is how Tiffany got that number a minute ago. It was 0.8825. It's what?
I just put it all in at once.
Yeah, you can put it all in at once. You need to be, as long as you're confident with your calculator skills, you just got to be sure that you get everything in so the calculator understands the right way to find it. Now, let me show you something. Okay, we'll go back to, oh, actually, I think I just need to do this. Okay. Look at that. They went 3 places to the right. They got 0.882. Now, if you were telling me what that means, if my R value is 0.882, we've got what kind of correlation? I would say strong positive. And if you remember when we looked at that graph originally, it's the one you wrote on your paper on the front of this packet, then we do see that it is increasing. It does look kind of like a line. And so what we could say is, as the gross domestic product increases, the carbon dioxide emissions also increase. But we cannot say there's a cause and effect relationship there. Now, this is where it's really helpful with the technology when you've got a lot of data. Let me just show you this. You remember when we put these values in for Yellowstone, and I've got 25 ordered pairs in there. Do you guys know how to find the R value in the calculator? Would you like to know how? Or do you like that formula that we just did?
No.
Okay, if you would like to see a faster way to get the R value, here's what you have to do. Make sure you've got everything in L1 and L2. But if you've never seen this R pop up on your calculator somewhere, it's probably because you do not have diagnostics turned on. The diagnostics is what will tell you the R value. So, have you ever been in the catalog in the 84s? If you have, then you know you get there by pressing second 0. If you haven't, then we're going to take you there and show you how to find it. Okay, so once I'm here, I'll go second quit to get back to my home screen, and I want to go into second, and I'm going to press 0. So I get into the catalog. Now the catalog is set up to where it's already in alphabetical order. It's kind of like your index. So it's going to show me the A's. Notice this little symbol up here is explaining it's already in text mode. If I needed to get into text mode sometime, I'd press the green alpha key. This is already saying you're in text mode. So all I have to do, if I want to turn diagnostics on, I need to go to the section that has D's. So do you see a green D on top of one of these buttons? X to the -1 has the D, okay? So I'm going to press that, and it's going to scroll to the section of D's. Now that means to use this, I got to know whatever I'm looking for, I got to know what it's called. So in this case, we're going to turn diagnostics on. Now that I'm in the D's, I'm going to scroll down until I see diagnostics on. Notice there's a diagnostic off and a diagnostic on. Be sure you're at diagnostic on. Hit enter. It's going to blink at you until you hit enter again, and they haven't been turned on until it says done. Okay, everybody there? Now, do this. I know you've done this before. What if I had asked you, we've got X's in L1, Y's in L2. Could you give me the equation for the regression line, or the equation for the line of best fit? Do you know how to find that? Okay, where do you go to get that?
Stat.
We go to stat, we go to calc, and which one do we choose? Number 4 would give us a linear regression. So I'm going to hit enter, enter. Now, if you have this operating system, it says store regression equation. If you have an older one, it came up with LIN, REG, AX plus B, and it's blinking at you. If that's what you have at this point, before you hit enter, I want to do something. I want to tell the calculator, not only do I want you to get the equation, but I want you to put it in Y1, because in a minute I want to graph it, and I don't want to have to go type it in Y1 myself. So how would I put Y1 here? Do you know?
Alpha trace.
You see the button that says bars? Press bars. Arrow over to Y bars, and where it says function, hit enter, and there's your list of Y values. And I'm going to hit
the TI-84 silver one. If you push alpha trace, you can just pick the list right there.
Okay, there's other ways. Remember, that's the thing. There's other ways to get there. But you want to get Y1 right here, and then we're going to calculate. Look at your screen. What do you see?
A whole bunch of wow.
A whole bunch of wow. I agree. I could write the equation. The only thing that's kind of goofy, they use A instead of M for slope, but I could write it. But now what else is there that probably hasn't been there before when you've done this? There's an R squared and there's an R. We don't need R squared in this course. We won't be using that, but if you take a higher level stats course, you might need it. But there's our R value. If you remember the Yellowstone scatter plot, it was pretty doggone linear. Look at what the R value is. 0.9787. I would say that's a very strong positive correlation, wouldn't you? That's pretty cool. So if you have the graphing calculator, then you can do this very quickly. And there we go, 0.9787 is what that would round to. So it's a very strong positive correlation. Now, I do want to remind you the fact that you've got a strong correlation doesn't imply cause and effect. So it's possible instead of X causing Y, maybe Y causes X. I don't know. Or there could be some other variable I haven't even thought about that's actually causing this relationship to occur. So you got to be careful that you don't assume things that we don't really know. Now, I do want to show you this real quickly, because I had you put into the Y1 this equation. Let's go look at the graph now. Remember, we set the window for the Yellowstone scatter plot earlier. Now if I hit graph, that's kind of cool. It actually shows me where that linear regression belongs in relation to all those points. Because when we get to section 9.2, and I don't know that we're going to be able to do it today, we'll probably have to start with that on Tuesday. That's where we would learn how to actually calculate that regression line. There is a formula for it, and it's almost as nasty as the one defined R. Have you had to do that by hand before, where you found your line of best fit without using the calculator? Okay, it's not fun, is it? Because basically what we're doing on this line of best fit is we're trying to minimize the difference between each of these points in the scatter plot and the line. And that's how we determine where the line belongs and what it is. And so you can do it by hand, but the calculator does all of it for you pretty nicely. So that's everything in 9.1. I will tell you, you can probably get your homework done in 9.2